Hello everyone, welcome to ET Studios, and today we're having a look at a new episode of my journey to thrust vector controlled model rockets. Today I'm going to go over the last two flights of the PABLO 1 rocket, as well as the flight data from the second flight, and what the project has coming up, and a few more updates and things like that. So, first I'd like to go over the fact that we have a new flight computer, which is actually very similar to the one that was on the breadboard, but it has been finalized. It was put onto a perf board or a protoboard, soldered on, and then connected to the 9-volt battery and fitted inside the PABLO 1 rocket. I'm very proud of this design, and overall, I'll just go through the specs quickly. It has a BNO 055 IMU, as well as a BMP 180 to give us altitude, a 256 kilobyte flash chip, as well as an Arduino Nano at the core, an RGB LED to tell you what mode it is in, and a buzzer. Similar design to the previous one on the breadboard, just better and more solid. So we're going to move on to the flights now, but I thought I'd mention the fact that the computer looks different now because this is the final design, but still the same concept as before. First flight of the PABLO 1. The rocket was built in about 2 weeks, the design phase included, and it's made out of a cool backing board plastic material for posters, which was turned into a cylindrical shape using a PVC pipe on the inside and then a lot of tape. It's not an optimal design by any means, but where I am, it's very difficult to find actual hobby materials, and cardboard tubes that are light are not actually as easy to come by as I thought. I've now found one that I will use for the next rocket, but I need to 3D print a whole bunch of stuff because it's a bit bigger, but that will be coming soon. So we're going to move up to 29mm motors and go a little bit higher and a little bit faster. The first flight is on YouTube as a separate video if you want to see all the camera angles and things, but essentially the rocket went up, it came down, the parachute came out, and it landed successfully. We lost one fin, which is lost forever. Unfortunately, it landed in the pineapples and is not retrievable. We couldn't find it. The lower stage had some damage to it due to a little bit of extra heat that I wasn't anticipating. As soon as the ejection charge came out, I think that a lot of heat left behind inside the tube led it to deform a little bit, and it no longer fits on a launch rail. But overall, a successful flight, and I rebuilt the first stage and flew it a second time. The second stage was perfectly fine, and we put the flight computer in. It was a lovely flight up until when the parachute should have come out, where it didn't. But overall, I actually consider it a very successful flight because the flight computer survived. It worked, it detected launch when it was supposed to, and the altitude data that we got was pretty accurate, I think. It looked about right. It didn't quite go as high as the first flight because it arced over a bit, and then when it hit the ground, there was a bit of data corruption. That is why the data you're looking at right now has weird shapes towards the end of all the graphs. Acceleration data was all over the place after the first 1.8 seconds, which is the burn time of a D12 motor, which is very nice to see. The data recorded was 100 milliseconds apart, and I'm actually very pleased with it, and I'm super happy that the flight computer worked. I've now realized why there is a bit of data corruption towards the end. The ground line on the flight computer has come loose in one place, and with a bit of vibration could definitely have been going between connected and not connected, so we had a whole bunch of weird data that was logged there, which isn't too surprising, I suppose, considering that it was under quite a lot of stress, but that can just be resolved and sorted out. The flight computer itself is quite cool. I'm very pleased with the design, and the buzzer inside is actually really loud. I could hear it from quite far away, so that was nice. And I went up to the rocket after the parachute hadn't deployed, and I think if we had had 5 more meters of altitude, it would have been fine, because the D12-7 has quite a long ejection delay of 7 seconds, and because it didn't quite reach as high of an altitude, it didn't have enough time on the way down before the parachute was supposed to come out, so if it had a little bit more altitude, the parachute would have been fine, because when I got to the rocket, the actual parachute was out of the rocket, so it would have deployed if it had a bit more altitude. Anyway, moving on, the flight data, extremely happy with that, and I will be flying it more often. I can bring down that 100 milliseconds to about 75, and the rest of that is all down to the speed of the CPU and the speed I can store stuff on the little flash chip I have, just because the methods don't let me store faster. It's just a limitation of the libraries, I think, which I could probably try and fix with a better flash chip or even just better code, but 100 milliseconds is perfectly fine. That's 10 times a second, so it's all right for now. I might want to fix that for like much further on towards when we're actually doing TVC. But eventually I want to use a TNC, probably a TNC 3.6 for actual thrust vector control. And if I do, then we'll have much faster processing power. And I'll use the onboard EEPROM for all storage because there's 4 kilobytes, that's the one, which is perfectly fine for storing this amount of data. The onboard EEPROM on the Nano is only 1 kilobyte, which isn't enough at the moment. But 4 kilobytes is plenty. I would like a bit more. But to start with, I think the onboard EEPROM will be fine because that means we have the quickest storage. I believe the methods for the onboard one's nice and snappy. The next rocket launch will probably not be the PABLO. It might be, but probably not. I'll be 3D printing the parts. I say it's not my 3D printer, but I'll hopefully be 3D printing the parts for the new one, which will be a very similar design, just a little bit larger and fit for 29mm motors. I'll probably start on an E15 and move up to an F23, and that should give us an altitude of about 350 meters on the F and 280 on the E, which is pretty cool. I've simulated it quite a lot in OpenRocket with the approximate masses of all the 3D printed stuff and the cardboard tube, which I already have. If that works out, it'll be fantastic. I need to do some modifications to the code because right now I can only store numbers up to 255 in each address, and I'm only using 1 address per piece of data. So I do have a bit of extra storage lying around, and I'll probably use that to just double up. So I have 2 bytes of data for each bit of information. I shouldn't say bit, but each piece of information will have 2 bytes of data, and I'll just add the 2 numbers. So I'll say if it is more than 255, then take the number minus 255, store the first one in the first byte and the second value in the second byte, and we add them together once we retrieve the data. That way I can store values up to 512 or 510 in this case. But yes, it's a lot more, and that's good. So I'm excited about the next flight. It should be quite cool. It'll go a lot faster. I still have to build the rocket, but I'll probably make a video specifically about building it because I really didn't do that for the PABLO. I do apologize. I do have some footage of it, but it's really not extensive, just because it was something that would have taken much longer if I had recorded and not been the easiest thing in the world to do. I know right now we haven't really got to thrust vector control, but it's going to take a while. The series is going to be quite long, but eventually I promise we will get there, and right now it's all about just learning how the avionics will work and getting myself used to the hobby in general, because the PABLO rocket is my first scratch build and my second ever rocket. So I'm still fairly new to the hobby, and I'm going straight from ground up all the way to thrust vector control and further on later. So if you're interested in that and you're interested in the series and you haven't subscribed yet, please subscribe and like the video if you enjoyed. There's a Discord server below if you'd like to join that, and a Patreon if you want to support the channel and help me buy these rocket motors, because they aren't particularly cheap if you're buying lots of them, so that would be highly appreciated. Greatly appreciated, I should say. And yeah, so if you enjoyed the video, please leave it a like, and leave any comments if you have any suggestions, etc. Join the Discord server, and I will see you in the next video. Thank you everyone for watching, and goodbye.